Shashank and welcome back to my channel Meenakshi Tobirti. So today here we are on the second video of some basic concepts of chemistry which is completely NCERT based. Okay, so let's see the agenda first. Before going into the video, please like, share and subscribe to my channel so that it improves my content and increases my interest. Okay, so today our agenda will be Dalton's atomic theory. We will discuss about Dalton's atomic theory. We will discuss what are subatomic particles. We will discuss atomic number and atomic mass. We will discuss what are atomic species also. Okay, so in the previous video, if you haven't seen my previous video, please click on the link, or you can go into my channel and view it. So in my previous video, it was a very basic video actually. It was completely about introduction to chemistry, what is matter, okay, and what are atoms and molecules, and we have elements and compounds. We discussed what is matter actually. Okay, in the next video, we will be discussing valence electrons and deeper about atoms. We will discuss Lewis dot structures and we will discuss what is chemical bond and we will discuss what is ions. Okay, let's go into the topic. Okay, and one important note is if you want notes are available. It will be there in the description and also in the comment section. You can go and view there. Okay, so let's go into Dalton's atomic theory. Okay, so welcome back. Now as we were thinking, now we will be discussing about Dalton's atomic theory. Dalton's atomic theory. What actually is Dalton's atomic theory? Dalton's atomic theory is actually, let me say the secrets behind this. Actually, many scientists had started off thinking what is an atom or what is atmos. Long back ago, as per Indian philosophy, even Maharshi Kannad, he was also one rishi. He gave the idea of Anu and Paramanu, atoms and molecules, at a long time ago. Okay, so Dalton's atomic theory was one of such what we call theories or postulates. What are postulates? Just the points, what do they think. Okay, it may be correct. Okay, when Dalton gave this theory, actually there was no particular equipment to see atoms. Okay, this theory was given by John Dalton. Okay, it was given by John Dalton. Now it consists of these postulates. Now let's see what are these postulates. Matter consists of invisible and indivisible particles called atoms. Next postulate, I wrote it here. Atom is smallest unit of matter that can take part in a chemical reaction. Okay, atom is smallest unit of matter that can take part in a chemical reaction. Atoms of the same element are similar in shape and size but different from atoms that of other elements. Okay, atoms of different elements may combine with each other in a fixed simple whole number ratios. These are nothing but compounds. These were the different postulates in Dalton's atomic theory. Now what actually these postulates say? Let me explain that. Now matter consists of invisible and indivisible particles called atoms. As we know, atoms are invisible, and he said that they are invisible and indivisible. What does this term indivisible mean? Indivisible means that it cannot be divided further. It cannot be divided further. Okay, it cannot be divided further. So, but this was proven wrong. What were proven wrong? What were the merits of this theory? We will discuss in the next topic, drawbacks of Dalton's atomic theory. Okay, matter consists of invisible, and he said that those are indivisible particles called atoms. Okay, now let's come to this point. Atom is smallest unit of matter that can take part in a chemical reaction. Atom is the smallest unit of matter that can take part in a chemical reaction. What does that mean actually? It is the smallest unit, as we know. It is the smallest unit and it makes up the matter. Yeah, that can take part in a chemical reaction. Like in our human body we have cells. Cells are doing our metabolic activities indirectly. Even our cell does respiration. That respiration only we are calling respiration. Our respiration, the energy creating. So this is something. Cells are indirectly doing our activity. In the same way, we think that elements, compounds, take part in a chemical reaction and form new substances. But this is wrong. That is also correct, but that is an axiom. Means we have to think of that. Atom is smallest unit of matter. Atom is only taking part in a chemical reaction. Atom is only indirectly taking part in a chemical reaction. This is very important. This was a great merit. Okay. Now, atom of the same, and this is very important. Atom of the same element are similar in shape and size. What does it say? Atoms of the same element are similar in shape and size. So, I have an element. In this element, I have atoms. All the atoms are similar kind. When I compare this atoms with another element's atoms, so let me visualize that. So let me think, this is one element, black element, and this is one red element. Okay, black element and red element. Now he said that the atoms of this element are similar with respect to this element, in the atoms of this element only. Okay, the atoms of this element are similar to the other atoms of this elements. Okay, but these atoms are different with this. Okay, so these atoms differ with these atoms. Okay, this is what he said, but this was also proven wrong, I will say. Okay, but different from atoms that of other elements. Okay, atoms. Now let's see the next point. Atoms of different elements may combine with each other in a fixed simple whole number ratios. What is it? Atoms of different elements may combine with each other in a fixed whole number ratios. Means I have an atom. These both can combine and form a compound, as we have discussed this earlier, like hydrogen plus oxygen. These two are different atoms. Actually these are molecules only, but let me consider these as atoms. Okay, they form H2O. It would be like this. Okay, they look like this. So two hydrogen atoms are combining with oxygen atoms to form this new compound. Okay, these are the postulates of Dalton's atomic theory. Now let's see the drawbacks of this Dalton's atomic theory. Okay, welcome back. Now we will be discussing Dalton's atomic theory drawbacks. Okay, we are discussing Dalton's atomic theory drawbacks. Okay, in drawbacks of Dalton's atomic theory, out of 5 points, 4 points were proven wrong. Okay, but that started the thinking capacity in scientists. So let's see what was the first drawback. Indivisibility. I said right? Indivisibility. What does that indivisibility mean? Indivisibility means it cannot be divided any further. But it was proven wrong. Our next topic will be that only, the subatomic particles. In that, atom can be divided into, it contains neutrons, protons, and it has even electrons also. Okay, this is what actually atom has: neutrons, protons, and electrons. So indivisibility, this statement was proven wrong. Okay, next point, the same element, all atoms were same. We discussed this point, right? If I take the same element, all the atoms are same. But this was also proven wrong. Why it was proven wrong? Same element means they will contain same atoms, right? But we will have atomic species. In this atomic species, we have isotopes. What were isotopes? Isotopes are same element, but they have different masses and densities. Atoms of the same element are having different masses and densities. This is called concept of isotopes. Okay, this was also proven wrong. Different elements, all atoms differ in all respects, but this was also proven wrong. In the concept of isobars, there are different elements, but their masses and densities are same. Okay, these are called isobars. Whole number ratio, we discussed, right? Two atoms combines to form whole number ratios compounds, but I will show you one molecule. Okay, C6H12O6. Do they look like simple ratios? Or C11H22, so we have organic compounds, we have complex organic compounds, we have complex organic compounds which don't have simple whole number ratios. Okay, these are the drawbacks of Dalton's atomic theory. So let's go to the next topic, subatomic particles, to prove this indivisibility was wrong. Okay, welcome back. Now we have come to a new topic, subatomic particles. As we know, an atom. Now till now we discussed what was an atom, what were the theories of atom. Now atom looks something like this as per Bohr. This was about Bohr atomic theory. It looked like this. Okay, we are following mostly that for lower classes. From higher classes we will discuss quantum mechanical model. This all we will discuss in atomic structure, how they discovered these and so on. Okay, electron. So, and not electron actually, looks like this. Atom looks like this. This central is the mass point. All the mass is concentrated at the center. This is called nucleus. And around nucleus we are having some orbits. This looks like solar system, right? So we have orbits. These orbits are called shells, or sometimes they are called orbits. These are denoted by N. Okay, so in each shell they have a capacity. Now I have a capacity to eat 3 apples with an empty stomach. Like that only, shells also have some capacity. Okay, so these shells are having 2n square. What is n? N is the shell number 1, 2, 3, 4, or these are named KLMN. Okay, KLMN. N is shell number. Now 2n square electrons can be fit in one shell. Okay, now let me take the first shell. This is the first shell. 2, 1 square, 1 square 1, which first shell can bear only 2 electrons. Next shell can bear 2 square 4, 4 twos are 8, 8 electrons, and all the 4 have that capacity 2n square. Okay, now inside the nucleus we have protons and neutrons, and in orbits electrons will be revolving. Okay, now let's see what are these electrons, protons and neutrons. Electrons and protons are charge bearers. They contain charge. And proton and neutron are mass bearers. They contribute to mass of atom, and electron and proton will contribute charge. Okay, electron mass, it has charge but mass is very negligible. If you see electron's mass, it is 9.109 into 10 power minus 28 grams, which when we see, it is very small. So electron's mass is 9.109 into 10 power minus 28 grams, which is very small. Okay, so while considering mass of atom, we don't consider electron. Okay, charge, very important. Electron has charge. Charge of an electron is minus 1.602 into 10 power minus 19. What you have understand from here? Electron is negatively charged. Electron is negatively charged. So minus 1.602 into 10 power minus 19 coulombs. Protons have a mass of 1.602 into 10 power minus 24. This can also be negligible, but with electron it is not negligible. It is minus 24 minus 28. It has more mass. Okay, and its charge is equal to electron but plus. It is positively charged. Electron is neutral, means we have equal number of electrons and protons which have equal charges but opposite signs. Both cancel each other, and therefore an atom is neutral. Neutron is one of the subatomic particle only. Its mass is 1.605 into 10 power minus 24, nearer to proton, but it has no charge. It has a charge of 0. Okay, these are the 3 subatomic particles. Okay, based on these subatomic particles, their calculations, we have to do many topics in chemistry. Okay, so this is what about subatomic particles. Now let's discuss about atomic species. Okay, so we have a small concept left behind over, so let's cover this and end this session today. Okay, time is running up. So atomic number and mass number. So each element has been given with one atomic number, means you can consider them as serial numbers, and mass numbers. What is this mass number? The atomic mass, round figured. Okay, so Z, what is Z? Z is atomic number. Okay, atomic number represents the number of protons. Atomic number represents number of protons. We discussed that atom is what we call atom is neutral. If atom is neutral, proton is positively charged. So to make it neutral, what we have to do? Equally, I should take one more particle, both in same number with same charge. Okay, so number of protons, which is also equal to the number of electrons. In that element atom, we have equal number of protons and number of electrons. Okay, this is what atomic number is. What is mass number? Mass number is nothing but number of protons plus number of neutrons. As we have discussed, number of protons plus number of neutrons. What does protons and neutrons contribute to? They both contribute to mass of the electron. That is why it is given atomic mass. What is it? Atomic mass. Number of protons plus number of neutrons. We can also find number of neutrons by mass number minus number of protons. Okay, this is what our atomic number and mass number is. In periodic classification chapter, we will discuss in detail how this atomic number and mass number came. Okay, representation of an element. Representation of an element. An element is represented like this. It has a symbol. Okay, it has a symbol. I think you might know what is a symbol of an element. If you don't know, just Google them, like elements symbols, then you get a periodic table. In that we have hydrogen, helium, lithium, beryllium, boron, carbon, and we have 118 elements. That will be something like this. Okay, so if we see that each is given with one letter symbol, so we have hydrogen, we have helium, we have lithium, beryllium, like that. We have shorthand notations. Okay, so better you can Google it, or I will try to show the periodic table at the end of the end of the video. Okay, so representation of let me take hydrogen, represented as His. So its atomic number and mass number are represented like this. Okay, hydrogen 1, helium, hydrogen mass number, atomic number is 1 and mass number is 1. Helium mass number is 4 and atomic number is 2. This is how we represent these elements. Okay, so welcome back. Now we will end this session here. This is what a periodic table is. Modern periodic table of elements. Okay, modern periodic table of elements. Hello friends, this is periodic table as you can see here. So we have 118 elements in this periodic table. So we have learned 30 elements, that too till zinc, as you can see here in this 1, 2, 3. Okay, so by the way, thanks for watching. Like, share and subscribe.